So today what we are going to do is we are going to solve the questions related to the topics which we had learned in the last session. So we are going to solve almost 4 to 5 or 5 to 6 questions related to the topic. All the 4 properties which we had learned, and along with that the basic proportionality theorem, angle bisector theorem, and also the property of 3 parallel lines and the transversal. So let us begin with the properties wala question, which is base of triangle is 9 and height is 5. Base of another triangle is 10 and height is 6. Find the ratio of areas of these triangles. See, neither the bases are equal nor the heights are equal. So we'll apply the first property, which is that since the ratios of areas of two triangles is equal to the ratio of product of the base and corresponding height, therefore area of triangle ABC upon area of triangle PQR equals to base 1 into height 1 upon base 2 into height 2, which is 9 into 5 upon 10 into 6, which is 45 upon 60. So we get our answer to be that area of triangle ABC upon area of triangle PQR equals to 3 upon 4. So now we can write 3 upon 4 as area of triangle is to area of triangle ABC is to area of triangle PQR equals to 3 is to 4. And now let us solve the next question, which is in the given figure BC is perpendicular to AB and AD is perpendicular to AB. BC equals to 4 and AD equals to 8. Find area of triangle ABC upon area of triangle ADB. So from this figure what we can get is that the bases of the two triangles are equal and just their heights are different, which means that AB which is their base is which is height is BC. So here height BC is not equal to height AD, just their bases are equal, which is similar one, which is AB. So here we'll apply the second property, which says that if the bases of two triangles are equal, then their heights are proportional and as well as their areas. So what we'll do is triangles having equal bases have areas proportional to their corresponding height, which means that area of triangle ABC upon area of triangle ABD equals to 4 upon 8, which is nothing but 1 upon 2. So we can write it as area of triangle ABC is equal to upon area of triangle ABD equals to 1 upon 2. Now what we are going to solve is the third property, which says that in the adjoining figure segment PS is perpendicular to RQ, QT is perpendicular to PR, QT is perpendicular to PR, and segment RQ equals to 6, PS equals to 6, and PR equals to 12. Then find QT. We have to find QT. So what we'll do here is we'll first find area of triangle PQR, this one. So what we'll do is we'll apply the formula that half area of triangle equals to half into base into height, which will get to be 18 units. Now again we'll apply the same formula in the original triangle, and we'll get the answer to be QT equal to 3 units. So by this procedure we can get our answer. So now we are going to solve a question which is based on the fourth property. In the adjoining figure AP is perpendicular to BC and AD is congruent to BC. Then find area of triangle ABC and area of triangle BCD. So here what we can get to know is that the heights of the two triangle are equal and their bases are also equal. So what we'll get the answer is 1, and it is constant for all the equations of such. Now we are going to take some random questions which are that in the adjoining figure PQ is perpendicular to BC and AD is perpendicular to BC. Then find the following ratio. First ratio is area of triangle PQB and area of triangle PBC. So here what we can get is their heights are equal but their bases aren't equal. So what we'll write is BQ upon BC, as both of them are bases. Next one what we have is area of triangle PBC and area of triangle ABC. So their bases are equal but heights are not equal. So we'll write PQ upon AD. Next one what we have is area of triangle ABC upon area of triangle ADC. Their heights are equal, so we'll write them to be BC upon DC. And area of triangle ADC and area of triangle PQC, they have nothing equal, so we'll write them to be DC into AD upon QC into PQ. Now we are going to solve some questions related to theorems. So we have this question in front of us, which is that find QP with the given information in the figure. We have been given that Mn equals to 25, NQ equals to 14, NP equals to 40, and we have to find QP. So which property we'll apply here is in triangle MNP, segment NQ bisects angle MNP. So we'll use here angle bisector property, which is Mn upon Np equals to Mq upon Qp. You see again, Mn upon Np equals to Mq upon Qp, which means that 25 upon 40 equals to 14 upon Qp. So we'll write take Qp up and bring 25 down, and 40 will take up, so it will become Qp equals to 40 into 14 upon 25. We'll cut them short and we'll make them Qp equals to 8 into 14 upon 5, which also means that Qp equals to 102 upon 5. So sorry, 112 upon 5, which is Qp equals to 22.5 units. Next one we have is in triangle LMN, ray MT bisects angle LMN. If LM equals to 6 and Mn equals to 10 and Ln equals to 8, then find LT. So what we'll apply here is angle bisector property, as one line bisects an angle. So what we'll get is Lm upon Mn equals to Lt upon Tn. So what we'll write is 6 upon 10 equals to Lt upon 8. We have to find Lt, so Lt equals to 6 into 8 upon 10. So what we'll get is 48 upon 10, therefore Lt equals to 4.8 units. Next one we'll take it, but now we'll take the property of 3 parallel lines and their transversal, rather than taking many examples of angle bisector property, as I think you would have understood angle bisector property by 2 or 3 examples. So we have taken this one as an example for property of 3 parallel lines and their transversal. In trapezium ABCD, side AB is parallel to side BQ is parallel to side DC, which means that these 3 are parallel lines, and AP equals to 15, PD equals to 12, and QC equals to 14. We have to find BQ. So we'll apply here the property of 3 parallel lines and their transversal, and what we'll get is AP upon PD equals to BQ upon QC, and then we'll solve it randomly. So here we have the solution. Here I have written AP upon PD equals to BQ upon QC, which I just told you a few seconds before. So we'll put in the values, which is 15 upon 12 equals to BQ upon 14. Therefore BQ equals to 15 into 14 upon 12. So we'll shorten them and we'll make them BQ equals to 5 into 7 upon 2, as 15 and 12 will get cancelled by the table of 3, and 4 and 14 will get cancelled by the table of 2. What we'll get is 7 5 35 upon 2, which is nothing but 17.5 units. Now let us solve the last question of the session, and then we'll conclude our session. So next example what we have is, in the given figure, if AB is parallel to CD is parallel to FE, then find X and AE. So here also we have been given a diagram which in which we have 3 parallel lines. They have been shortened up by 2 transversals, and we have also been given their values. So, and we have to find CE, which is an X over here. So what we'll do is we'll apply the property of 3 parallel lines and their transversal. What we'll write it as AC upon CE equals to BD upon D. So now we'll put in the values as 12 upon X equals to 8 upon 4. So X will equal to 4 into 12 upon 8. We'll shorten them up and we'll get the answer to be 6 units. And now we have to find AE. So we'll write it as AE equals to AC plus CE, which is 12 plus 6. So therefore AE equals to 18 units. So guys, that's all for today. Today we solved many questions related to the topics which I had taught you in the last session. So hope you understood something from this, and also do like the video, share with your family and friends, and also subscribe the channel. put in your question in the comment box so that I can solve it for you and help you out with your problems. Thanks for watching and bye bye.